The topic of this video is to prove that if two circles intersect, they do so in exactly 2 points. For the purpose of this video, I am going to feign ignorance about the shape of circle. And the reason I am going to do it is, if you assume that you know the shape of a circle, then intersection becomes very intuitive and you really lose the motivation to prove anything. So that's what we are going to go with. Now, if we are going to pretend that we don't know what a circle looks like, what is it that we have to go by? So I pulled out definitions related to the circle from Euclid. Let's see what they are. Okay, he says a circle is a plane figure that is lying in one plane. That's taken care of because we are working in the plane containing my whiteboard. It's a curved line that closes on itself. We have already decided to ignore this. It has a peculiar point called inside it called a center, and the distance between the center and any point on the line is the same. So what we really have to go by is the center and the radius. So let's proceed armed with just these two things. Now, since we are talking about two circles, that means we have two centers, C1 and C2, and two radii, R1 and R2. I am going to break the problem down to be able to prove what we need to prove. And I am going to do a little bit of construction here, very simple construction. I am going to join the two centers, C1 and C2. I hope you can see that. And I am going to extend this line infinitely, so to say, on both sides, on the left of C1 and to the right of C2. This is the construction I have done, and to break the problem down, I am going to divide the plane containing the whiteboard into the following parts. Part number 1 is that part of the plane which lies above this line. Part number 2 is that part of the plane which lies below this line. Part number 3 is the segment C1, C2 itself. Part number 4 is that part of the line to the left of C1. And part 5 to the right of C2. Okay, now we get down to proving what we want to prove. Let's start with plane 1. Might these two circles intersect in plane 1? What we are really looking for is, if they do intersect in plane 1, what are the conditions? So I am going to define intersection for ourselves. Intersection of two circles or two geometrical figures is a situation in which the two figures share one or more point. They have one or more points in common. So might these two circles have one point in common in this part of the plane, part 1. Let us say that point is point A. Now, since we are going by the two elements we know about a circle, a center and a radius, if this point is common to these two circles, then it goes that this distance between center C1 of the first circle and point A is R1. Likewise, this distance is R2. So if this point is common to these two circles, then these are the distances, and I also go ahead and call the distance between C1 and C2 as D. What we have here are 2 points, and this one, clearly because it's above C1 and C2, we have 3 non-collinear points. That gives us a triangle, and since we have triangle, the principle of triangle inequality applies. And what is that principle of triangle inequality? The sum of any two sides of a triangle is greater than the third, which really tells us that if this is a common point across these two circles, then R1 plus R2 is greater than D, R1 plus D is greater than R2, and R2 plus D is greater than R1. Nothing stops us from having such a point. So as long as these conditions are satisfied, we have one common point between these two circles in this part of the plane. Might there be another common point B in the same part of the plane, part 1. If we were to have such a point B, it would have to adhere to the same conditions, right? So I quickly draw this line. This would be R1, and this distance all the way here to C2 would be R2. So essentially we have 2 points A and B which are situated at such distances from C1 and C2 on the same side of C1 and C2, such that this distance is R1, so is this, and this distance is R2, and so is this. Now this is not possible. It's proven, and I quickly quote proposition 7, book 1 of Euclid. I'm not going to read it out, but I have proven this, and you can also take a look at this proof. So we cannot have 2 points on the same side of C1, C2 satisfying these conditions, which means that in effect we conclude that in part 1 of this plane, if we have a point of intersection between the circles, it can be only 1 point. How about part 2? Can we have another point here which satisfies these conditions? So you know what I'm going to do? I'm going to draw, and I'm going to use my makeshift compass. I'm going to draw a triangle which is congruent to AC1, C2 on this side. Okay? Now I'm going to take this distance. Okay. I'm going to erase these markers and just leave the point of intersection. I call this point B. Let me join point B. Since I had marked these distances, we know that this is R1 and this is R2. So this distance is R1 and this distance is R2. Not only that, these two triangles are congruent, so really this point adheres to these conditions. So we found another point which really satisfies these conditions. So we found 2 points. So we have actually proven that if two circles intersect, they do intersect in 2 points. What remains to be proven? Can there be a third point? Can there be a fourth point? Since we have already covered this part of the plane and this part of the plane, we are really left with part 3, part 4 and part 5. How about part 3? Okay. If I were to have a third point here, C, look what happens. Okay. If C were another common point on the circle, then this small distance would be R1, this distance here would be R2, and we already know the whole distance here is D, which really means that we have a situation where R1 plus R2 is equal to D. That breaks this condition. And since we cannot find another point which would adhere to the same conditions, we can safely conclude that it is not possible to have one more point of intersection of these two circles, at least on C1, C2. How about part 4? If I were to have a point C here, what we have is this distance is R1, this whole distance is R2, and this distance is D. So we really have R1, let me write it here, R1 plus D equal to R2. And if you look carefully, that violates this condition. And hence I conclude that it's not possible to have a third point of intersection on this part of the line, of the plane, in this extended line. If you quickly think about it, you'll reach the same conclusion for this part of the line. If you were to have a point here, then what we would have is R2 plus D would be equal to R1, and that would violate this condition. So you can't have a third point of intersection between these two circles here either. If you now think about it, we have covered the entire plane and we have concluded that, and we have proven that if these two circles do intersect, then they intersect only in these 2 points. 2 points and 2 points only. That really concludes our proof. Now let's have some fun, because let's shed our pretense of not knowing the shape of a circle. Now since this is R1 and this is R1, circle 1, this is kind of how it really looks. Now this is a familiar shape. I am sorry, I am still not used to drawing with my makeshift compass. And if you were to take R2, then the second circle would really present itself like this. This now gives us the familiar figure of 2 intersecting circles. I am short of time. I need to restrict this video to 10 minutes. Now, why did I do it this way, using triangles? I think, this is a very good way of giving us a deep insight into the topic of circles. More importantly, you will always come across such assignments or such problems. I'm not going to read it out, but do read it. And if you have your basic concepts clear, then you can really tackle these problems very quickly, very intuitively, and very confidently. I hope you liked this video. Till the next one, this is bye from me.